Bismillahirrahmanirrahim. Assalamu alaikum. My name is Muhammad Asim. I'm working as DevOps engineer. In this video, I will be covering the EKS Autoscaler, and in my past videos, I've already covered how to deploy EKS through the Terraform, and we will be using the EKS CTL. All deployment is going to be through Terraform. So what I've done, I've created a fresh repository for you guys, and what you have to do is to simply clone this repository, and we will be deploying all the infrastructure on AWS through this repository. So I'm going to simply clone it via the HTTPS. So navigate let me navigate to the host machine, cd to desktop, and I'm going to simply clone it. So I clone it, and I'm going to move this guy to this container, and this container is this one. So I have my AWS console here. I'm going to take a shell into this container, and I've already made videos with regard to this, how you can use UI in the container, and if you are interested, you can do that. Have a look at that particular video. And I do all my work in containers, so it's really highly secure, and I don't have to install the packages on my Windows host machine or any host machine. You can install your packages in container and do your work. Chrome is available, and all of the stuff is going to be available in that particular container. So what I will be doing, first of all, let me show you the stuff which we are going to deploy. So will be deploying the, let me keep this guy here, and we will be deploying, first of all, we need EKS cluster. So the cluster name is going to be this Cloud Geeks EKS, and I will be deploying through the Terraform. And let me navigate to the main.tf. In main.tf, what I will be doing, that I'm going to set up my backend with Cloud Geeks Terraform bucket, and I'm going to deploy a particular VPC, and in that particular VPC, I'm going to deploy my EKS cluster. And this time I'm using the, not my custom module. I will be using the HashiCorp default module, and you can use that as well. So it is really very powerful. So all the tagging, all the stuff with regard to the EKS which will be needed, so I've added here, so you don't have to do anything. Simply, change your status and change the settings whatever you want. The site range, all the stuff is going to be available. So these are the tags. If you uh, want to, definitely we are going to install the ingress controller, ALB ingress controllers. So we need these tags, so it must be present. So in case of internal load balancer or external load balancer in your public and private subnet should have these tags. So anyway, we are going to then deploy the EKS cluster in that particular VPC, and I'm going to show you this particular script as well. Along with that, I'm going to also install the ALB ingress controller. All is going to be through the Terraform automation, and then we are going to set up the CSA controllers, and then we will also be installing the secrets. Although this CSA controllers, secrets, all this stuff is not needed, but I've added the automation. If you need this stuff, you can simply clone my repo and simply deploy that particular repository or Terraform code for your production need as well. So it is pretty much production ready stuff. So what we are focusing in this video is with regard to the autoscaler controller, what how you can do that, and this is also automated. I'm just giving you the demo with regard to the scripting I've needed. The scripting I've created for you guys, the automation, all the process is going to be pretty much automated. So what I will be doing, so first of all, let me source this EKS, I am sourcing it because the name of the cluster is going to be automatically updated. So I've cloned the repository. When you clone on the host machine Windows, what you have to do is to simply move the stuff from DOS to Unix, because this container is completely in Ubuntu. Let me show you that. So if I do cat OS release, you will see that we are using the pure Linux. Yeah, and it is hosting actually hosted on the Windows, so that is why it is giving us errors. So it is 1804 Bionic server anyway. So what I will be doing, I have to simply do this stuff, and also I'm going to do for all shell files which I've had here. So it is converted. So simply I'm going to use the source command. So it is now updated. So what I will be doing, simply navigate it to my command section from here. What you have to do is to deploy this particular VPC. So why I'm using this command, why I'm not using Terraform apply auto approve. The reason for is that let me first of all create the backend, which I have forget to add. So I'm going to create a custom S3 bucket for our backend, and then I have to initialize as well. So I'm also enabling the versioning here as well. So I'm going to say Terraform init. So what it does, it will install all the relevant modules which we need for our Terraform code. And with regard to this command, I need to update you that what I will be doing, the output of this command is going to be the input to other scripts. So when the Terraform file is busy, the output is not going to be available to those scripts. So that's why I'm using this command for the deployment of VPC, and then I'm going to simply use this particular command. So let me simply copy and paste this, sorry, paste this particular command to deploy the VPC. So as far as the VPC, it is pretty much self-explanatory that you have already seen what side the range is and networking we need or I need for my EKS cluster. So you are seeing that I'm using the /20 cider ranges because that is the reason why I'm moving to EKS, that I need to deploy hundreds of pods in those subnets. So that's why this range is high, and it is the 2 raised to power 12. And the other database, definitely have not need lot of IPs. So and that is 2 raised to power 8. So a bit of math here. And so what I will be doing here now, you see our VPC is in progress, so it will take a little time. I mean, definitely, I would like to deploy my stuff in secure infrastructure, so that is why I need to do this. So let it complete, and also let me show you some of the stuff with regard to the calculator 2 raised to power. Okay, 2 raised to power 8 is 256, which is for the database, and 2 raised to power 12 is going to be 4906 IPs are going to be, which are the private IPs which are going to be available in my both public and private subnets. So this is just for your information. That is why I've used the CIDR ranges. And then um, I'm moving to the next step, which is with regard to the deployment of EKS cluster. So let me navigate to the EKS cluster. So as I told you that this is the name, and for let me show you the variable, and this variable is going to be updated in the Terraform automatically, which is going to be in available in the EKS CTL script as well. So this is the script, and for Terraform variable TF bar is the default standard which through which that Terraform reads the variables, environment variables. So that is why we have sourced those environment variables, and this is going to be updated, and it is going to be available in Terraform EKCTL script. So as I told you, this is the private subnets. I'm out giving it the output of the private subnets to my private subnets, and output of public subnets to these variables. And then I'm going to create a custom key, and that information, you see, these are pretty much variables, and this all information is available. Which you need to update is simply in this EKS env file. So if you navigate to this, you see this is the cluster name, this is the EKS version I need to deploy, this is the region, node type T3 medium, total nodes, I mean the desired nodes, and min maximum nodes, which is for auto scaling, is going to be this one. So node volume size is going to be 30 GBs, and SSH key name is going to be this one. So you just need to update this information according to your desired naming convention and needs of compute instances. So what now we have to do, you see our VPC is created. Let me show you the VPC. So, and in that particular VPC we are going to deploy our EKS cluster. So simply type VPC here. Okay, navigate to the VPC section. You see custom VPC is created. Till then, definitely it is going to take some time. I will be pausing the video later, but let me paste this particular command to deploy this EKS cluster in this particular VPC. So I just have to do this, use this command, and what it does, it is going to deploy all the stuff which we need. For instance, it is going to deploy the EKS cluster, along with that ELB ingress controller in automated way. I will be showing you guys all the script which I've created and all the automation, and you don't have to do the stuff manually. Simply have to paste this command, and these are the only two commands you need to deploy the EKS, Elastic Kubernetes infrastructure in AWS, which will be very secure and deploy all the relevant drivers and controllers for you in an automated way. So, the video length might be only in a way that I will be explaining the scripts and the automation. Otherwise, it is pretty much easy stuff I've made you for automation. If you see my past videos, I do like automation, and all my videos are based on the automation. The time you will actually see is pretty much with regard to the explanation what we need. So I've covered the EKCTL shell script, so let me show you that part. So now I will be covering to the next step, which is the ALB ingress controller. So for ALB ingress controller, what we have, ALB ingress.shell. So this is the script. This is the script where we will be deploying the ALB ingress controller through Helm charts, and it is going to deploy that particular ALB ingress controller in an automated way in our EKS cluster. So we have already sourced this EKS env file. So in this particular shell, it is going to be available. So other part, now let's move to the other part, and other part is going to be the EBS slash secret store CSA driver. So I've actually create a separate resource for this. So let me update this for you guys. So we are going to use the EBS driver. Let me update in the repo as well. So you will see that everything is going to be separated, and it is going to be easy for you guys to understand, and the scripts are already available. So let me pause the video and update the repo as well. So guys, I have updated the repository as well, and now navigate to this script. So it is ebscsa.shell. So what we have in this script, we are going to fetch the AWS account ID through this environment variable, sorry, through this variable, and this is through the AWS STS, AWS CLI is going to do the job for us. And then we will be doing the automation through curl, and role name is going to be through the regex awk. I've used it, grep, I've used it. So you don't have to do all that much. So what it does, that it is going to deploy the EBSCSI driver in your Kubernetes cluster through Helm. So that is pretty much it. And with regard to the detail, I've covered in my previous video, so that is why I'm not covering all the stuff in this video. So I'm giving you just the basic details. So if you want to see the details, you can watch my other videos where I've covered the detailed video with regard to the EBS CSI controller, what it is and how you can use it. So then I will be covering the secret stored driver, and with regard to this, the script we will be using is the secret manager dot shell. And if you see this secret manager dot shell, what I'm doing here, that I'm going to cd into this secret manager, and I'm going to use the kubectl to apply the CSI store driver and AWS provider installer. So I have this directory available. In this we have um, AWS provider installer, and all these YAML files are going to deploy the rollback access control, rollback access control binding. So everything is going to be needed for that particular secret manager. So I already made these videos with regard to the secret manager in Kubernetes, how you can use that. And so just I'm covering the whole infrastructure. That is why I'm giving you the hint with regard to that stuff. So if you want to see that, you can watch my video in detail, so how it is used and what are the benefit of using the secret manager in Kubernetes. So this part is done. Now we are covering to our final part. This is the video which I will be covering in this, which is with regard to the cluster autoscaler. So let me show you guys where we are currently right now. So you see, for EKS, what the advantage of using is that EKS is maintained by vworks. So all the stuff with regard to the automation, it is going to deploy the cloud formation templates, updated and every stuff. The manageability of EKS cluster is going to be very much easy if you are a DevOps, if you are looking to manage all the stuff through the CLI and through the automated way. And it is the most recommended way, by the way. I need to tell you that it is highly recommended to use the EKS CTL. So that is why I'm using it. I've already made the video with regard to the how you can deploy EKS through Terraform. So it is a complete video, but then I uh, focus more toward the EKS CTL. So everything is pretty much automated way through the Terraform, but we are using the EKS CTL, and Terraform is a wide tool. It has a lot of benefits, and it gives us the advantage to use the EKS CTL even in our Terraform code in an automated way. So that's why I'm using it. So if I navigate to this directory, this is the cluster autoscaler. So let me close the other directories as well. So what I will be doing, navigating to this directory cluster autoscaler. So again, I have a automated script created for you guys. This is the cluster autoscaler shell script. So simply click it, and this is a bit lengthier script. There, what I have done is to eliminate the manual stuff, which is quite a bit lengthy. So that is why I'm just using the terraform apply autoproof command, and all the stuff is going to be deployed through an automated way in our Kubernetes cluster. So let's begin. As this is the account ID, it is going to fetch the account ID policy. We are going to give this EKS cluster policy namespace. I will be using definitely the kube system is the namespace where all the system related stuff for Kubernetes is going to be and should be located. So service name is going to be the cluster autoscaler CF template for autoscaler. So what this automation does that it is going to actually create a cloud formation template at the backend. So currently we don't have any EKS cluster. So if you navigate to my code, you see I'm using depends on null resource EKS. So after the EKS cluster is going to be available, then that all particular uh, driver are going to be automatically deployed in our EKS cluster. So for that, if you do it manually, it will take a lot of time. So as you see, just I'm explaining the stuff. Everything is pretty much automated. So it will create the stuff for us. As you know that EKS cluster will take 15 to 20 minutes. So that's why I'm explaining the stuff. Although I can pause the video, or definitely the size of the video will be lesser than. So but this video will be really helpful for you guys to understand what we are actually going to deploy. So this is the actually cloud formation template, and I'm using this variable which is going to be like this way, uh, that the cluster name is going to be then, and then I am service account namespace is going to be kube system, service name is going to be the cluster autoscaler. So then what this variable does, EKS cluster autoscaler. So I'm using the AWS CLI command to fetch the output of this cloud formation template, and the values are going to be coming from this variable. So this I've already covered. So um, this gives us the role ARN. So we need role ARN in later stages of this script. So then what we will be doing, we will be using the EKCTL OIDC provider. Instead of creating it manually, we will be using the EKCTL utilities. That is why the advantage of EKCTL is very helpful for us for the automation, deployment, and manageability of EKS cluster. So we'll be updating this cluster through EKS utils, and I'm going to create a custom policy, and this policy is going to be available. So this policy gives the service account which we will be creating, which is the autoscaler service account, and this policy will be automatically attached to that particular service account. And this that service account has these permissions with regard to the auto scaling, and auto scale out and scale in ability is going to be available for that autoscaler. So let me go back to that. I've closed it. So this is the policy I've discussed, and then we will be creating the IAM service account as I discussed. That service account is going to be the name of that service account is going to be this is the service name, and this service name is cluster autoscaler. So I discuss that service account will have that particular role attached automatically by using the EKSCTL create IAM service account. So this is the full command, and this is the policy we will be account attaching to that particular role, and this is the full command. So I just need to give you a basic understanding. So if you are not using the ekctl, you can do that through the kubectl command as well. I've also added those command as well. For instance, you can use the kubectl annotate command to that particular service account, and you can attach a role ARN, and that particular role ARN has that particular policy which we have created above and already discussed this. So with this ekctl command, it does all the stuff for us in a way that it is going to create IAM service account. Okay, it is going to also create a cloud formation template with a role, and we are attaching the policy as well. So every three steps which I have discussed is going to be covered in this single command. So that particular service account is included. You see, that is the cluster autoscaler in our CAS cluster autoscaler. I'm calling this cas.yaml. You can call this any name. Um, so this has the ability and all the rollback which it needed. So you don't have to focus much on that, because the links are already provided. You can read all the detail with regard to these in the, let me show you that in the AWS documentation. So I've already added 4 or 5 major links. All the documentation which I have covered in this automation is going to be available for you guys. You can read that, and it is from AWS. The advantage of using this module is that you don't have to do it manually, and all the stuff which is required for the deployment is going to be automatically available. And we will, in the final section, I will be showing you guys the scalability of our EKS cluster. So in last, what okay, let me cover this part as well. So this is very important, and that is where I will be covering I mean which image we need to have. So version is going to be this one, which is according to your EKS cluster. For instance, I'm using the EKS cluster version 1.21, okay, or 1.21. So this is the version I'm using here. So I'm that is why I'm using this. So if I navigate to the links section, so let me open the important links for you guys, so you can have understanding where to take the values, and it is going to be much easier for you guys to understand, and all the documents uh, I will be providing. So this is the cluster autoscaler AWS documentation. You can read those and all the tagging stuff. So as we are using the automation uh, through the ekctl automated way, this is going to be automatically available. But if you want to read, you can read all the stuff from these links. So this is the second link with regard to the cluster autoscaler. So you can click the releases, and if you navigate to the release, so as I told you that I'm not using the 122 version, I'm using the Kubernetes version of 121.1. So that's why I've used this one. So if you have old version, you can use those. So um, this is the stuff with regard to the image. You can update the major and minor versions as well. So it is totally um, available in my links as well, and every recommended link is available. So I just want to give you this idea. You can read more on that. So might be this is okay. Second time I've added it, I'm going to remove it. So let me navigate to this guy, you see the CloudFormation template for the EKS cluster is available, but the automation with regard to the nodes are going to be done in the second phase, and then when the EKS cluster is fully available, then our driver installation is going to be done. Till then, what I'm doing, I'm going to pause the video and I will be back with you guys in a moment. Thank you. So guys, and just for showing you guys the deployment phase of our worker nodes are in progress. So if you navigate, if you want to see from the UI as well, that is where we are creating the CloudFormation templates through the Terraform, and we are using the EKCTL. So that is the power of Terraform. We can use the automation and all the stuff through the Terraform. So it will take a little while. So once it's done, I'm going to show you all the stuff with regard to the cluster autoscaler, and I'm going to cover the scaling commands with regard to that. So guys, our deployment is completed, and let's see what we have in our cluster. So what I will be doing, I'm going to use this command kubectl get all in all namespaces. So I will have all the stuff in my all namespaces is going to be available through this command. So as you see, let me show you this is the deployment of cluster autoscaler is now available in our cluster, and what we will be doing, and this is the pod running in our cube system with the pod cluster autoscaler. So this is up and running. So what now I will be doing, so I'm going to take another shell in the different namespace. So what I will be doing now, I'm going to first of all simply show you guys the scaling part. So what we will be doing, um, I'm going to use the simple command, and the command I've already available for you guys in this so in this section of cluster autoscaler. So Kubernetes deployment, this is the image I've created. So you simply have to copy this command, and let's say it's my first deployment in this demo, and I'm going to create this deployment. So it is in the default namespace. So let's say if I say kubectl get all in default namespace, I will be able to see the deployments and pods if running. So deployment is definitely going to be available, and then I'm going to scale the pod. Sorry, yeah, I'm going to scale the pod. So by default, this is the first deployment. It is running. That's fine. We have one EC2 machine here. Let me navigate to that EC2 stuff. And other than that, let me show you this cloud formation template, which is created by the script, which I've already covered. That it will set up the cloud formation for template for us, and it is going to be the service account, and in this service account I'm fetching the value of this resource, which is the um, role attached to that autoscaler, and in the output section this is the role I'm fetching through that particular script. So all that is why everything is automated. So this is the ARN which is used by this autoscaler controller in the service account. Let me show you that kubectl get service accounts in namespace cube system. So let me show you the detail with regard to that, which I forget it. So let me just move this guy here. If you navigate to this controller, where I should see this, Cluster Autoscaler. Yeah, this is the service account, and we have what we have done. We have attached a role to this service account, and in that particular role, we have a policy. That is how it is going to scale out and scale in uh, our deployment. So currently, let me show you that from the UI and from the CLI as well. I will show you. This is the one node we have. Let me simply type the EC2 here, and this is the one worker node we have in our account. And if I do kubectl get nodes hyphen o wide, give us some more detail of our nodes. So we are using the 121 version of Kubernetes. It is ready, Docker and all that stuff. So it is one node, and you see, yep, navigate to this EC2 section, and this is the only worker node we have in our uh, account, in this sandbox account. So now I will be doing, I want to scale this deployment which I've done. So currently we have only one pod, but of course, let's say assume that there is a load of traffic, lot of customer now using your application, and automatic scaling happen, and it is now scaled to, you set up the scaling policy in your Kubernetes deployment, and it is, for instance, now we are doing it manually, but just for the mimic that we are our pods are scaled, but you will see that those pods are in pending states. kubectl get all in namespace default, because we have only one pod and there is no room for these pod to run. I mean, currently the pod which is living is running on that particular machine, but to run these 30 pod we need to have more machines. So you see, um, five are available on that particular machine. We have room to spin up four more pods, and we need a space, more space, a host machine to run those particular pods, which are which is going to be automatically covered by the cluster autoscaler. But for that, one thing I need to update you as well. If you navigate to the EC2 section, navigate to the cluster auto scaling group, and even from the EKS CTL shell script, which I've already covered, that um, let me show you this env file. So the total nodes is the desired is 1, min and max is 1 and 3. So if you navigate to the cluster autoscaler, you see the desired capacity is now up. It is actually changed from min to maximum. Desired is the total I shown you, it should be 1, but now if I navigate to that particular section, let me open it another tab, you will see the initialization of node is going to be happen. You see, you will see that two other nodes are going to be in initialization state, which is just begin. So that's why that state changed from 1 to 3, and those pods are going to be sooner available, I mean sooner in the running states. So let's see how many are those. But you see definitely, and the advantage of at autoscaler is that you see the running are now um, 29. You see it, these are the running pods now. So you see previously we don't have enough room to run those pods, only one is left. So 29 pods are available in service. So that is the powerful feature, and we can use through the we can use through autoscaling and yes, Autoscaler. In my next videos, I will be trying to cover the more powerful tool which is launched by um, AWS in 2021 reInvent as well, and it is open source, which is the Carpenter. So AWS EKS Carpenter might be the spelling. So it is more powerful than this autoscaler because it has the understanding, or it has the automation that what should be the size of that particular node according to your deployment of pods, what how much it need, and it is going to be really powerful tool which I'm working on it, and I will be covering in my future videos. So currently I have um, made a video for you guys on this, but this is going to be in the future definitely. But you can look at this carpenter stuff, how we can use it, and AWS is now offering, and even carpenter is now available for currently EKS as well. So it is the powerful tool if you have very much high infrastructure or high demand of scaling of pods and all that stuff. So now I'm going to simply what I will be doing, that I'm going to also scale down my pods. So if I navigate to the command section, I'm going to scale down to two replicas, and this will take a little while. I mean, it will take about 10 to 15 minutes. I'm not sure about the time, but the I mean, automation is going to be in a way that this when it sees that we have two replicas, I mean, two pods running, it is Kubernetes is going to definitely destroy those extra pods, but we have to pay the cost of other two scale nodes. But these two pods are going to be adjusted in a single node as well. You see, it is started the termination stuff. So um, so these two extra nodes which is spin up by the controller autoscaler needs to be scaled in, so we can save on the cost as well. But definitely, as I told you, as I discussed, that this process will take about 10 to 15 minutes, and I might show you guys. So you see, currently we have three nodes up and running, but our infrastructure is reduced, your load on application is reduced, maybe the business hour um, are now closed, whatever. So we don't have any load on our cluster. So we should have scaling, but that is going to be automatically done as well through this cluster autoscaler, and it is going to be done in few minutes. As I discussed, it will take some time. I'm going to pause the video, and I definitely want to show you that part as well. So guys, this is the last part I need to show you guys. This is the one you see. These extra nodes are automatically terminated after about 10 minutes or so. So if I do kubectl get nodes, you will see we should have only one node in our EKS cluster, as you see. And if you see the kubectl get deployment, and by default, sorry, I should type parse get all in namespace default, and you will see that there are going to be only two pods. So uh, these two pods only require one host machine, so we have two pods up and running, and you see we have one node and up and running. So if I navigate to the auto scaling group, you should be able to see that that particular number. You see desired capacity change from 3 to 1, and we have max number set, min number set, and this is the desired capacity. um, this capacity is definitely is going to be scale out and scale in with regard to the you know uh, when the load increases. So that is it, guys. If you like the video, please like, share, and subscribe the channel. Thank you very much. Have a nice day.